So here, let's see how we can specify or model the system using Z notification or Z notation. Okay. So here, what I said, that's in Z notation, actually uh, use we use the we use something like block. Okay, every schema or every part of the system, we model it in blocks, and these blocks we call it schema. Okay, so this is schema. Okay, you want, for example, you have your system, and one requirement of your system is to add user. Your system, it's able to add the user. So this is which we can say is adding user. It's operation, we can call it, right? Or we can say is the requirement, one requirement. Okay, so we model this one. We have this as a block, as a schema, and then we create this schema. Okay, so what can say each requirement can be, we can say that each requirement is as a block, and this block called schema. Okay, so this schema actually it's have two main parts. The first part is the declaration, and the second part is the predict. So in the declaration, we define the variables of the schema. In the predicts, we will define if there is any invariance, or you know that what's mean the invariance, right? So there, the invariance, that means something like a condition should be satisfied. So this is the same. So here, it's more details here. Actually, the Z specification here include the types. So we have the types. We should define the types of the system of the objects. Also, we have invariance properties, as we see here. If you see, this is the invariance, for example. We have this one. If we consider this as a structure of, or we can say as a, okay, person can be as a customer, user, student, anything. Okay, so this one have some information: the first name, last name, telephone number, and uh, card ID or card ID, card NB card, for example. So here, for example, we have invariant here. What we have here, the telephone number should not be zero. Should not be zero. So this is invariant. Something should be satisfied. So this is what we call it is the safety. Remember the safety or the care, the healthiness of the system. So this is actually is also the same what we say here in specification, in the Z specification. We model or we manage everything in as schema, and each schema actually is a collection of state variables and their value. You will see what's mean the state variables. Okay, if you remember open, we create the location, and then if the same location can be many state. Why? Based on the variables. So if the variable is changed, so this is one state. So in the next time, for example, these variables is changed. So now we have another state. So this is the same thing. So we have the state, but here it's clear. Here we have a state, and then we have some operation to change this state. Okay. So we have, as we see, is the invariants. We have the operations and variables. So here also the another things, it's we can consider the schema as two aspects. The first one is the static aspect. So what we mean by the static aspect actually is the structure of the system. So once we define, for example, as we see here, the person, and then we define this person have a name, and the person have a last name, a telephone number. So this is the structure, and this one will not change. The structure. I'm not talking about the data of the structure. The structure will not change. So this is the static aspect. So we can represent the structure or the static aspect in Z notation by defining the data types. We can see use the available data types, or we can create our own data types. Also, the state. The state is static. Why is static? Because it's actually is considered the structure or is define the structure of the, for example, the object. Okay, we have user, so we create state for this user. So now this state is static, will not be changed, the state. But later, the variables, once we change the data, this state will change. That means we change the data, but the structure, we define it in the state. We have the invariance, which is the relation between these objects. The dynamic aspect, which is the operation between the operation that's should be done on this state. Okay, also the relation between the objects, also the chain of the state chain. So now we, as I say, we add some, for example, we add one customer. So now we change the state. So this is all is dynamic. So here, guys, we come to important topics. Actually, as we say, we talk a lot about the state or the schema. So we have, in general, we can say we have two types of schema. Actually, we can say it's three. We can say it's three. The first one, actually, okay, this is the schema. We have schema. Okay, we have the first one. We can say is the state schema. We have initial schema. We have in any system, this one should be available, should be there. And the second one, or the old one, is the operation. Operation is more than one. This is maybe we have only one, and this is we have many based on our system. So here is this is the scheme. Actually, the scheme, as we see, is the basic block of the Z notation and the schema. We have different type of the schema, not different types actually based on our system. But we need to model any system these three type of the schema. The first one is the state, the initial, and the operation. Okay, the state actually is we represent the structure of the system. Okay, for example, as we say, we have. Okay, let's I explain one example here. We have it. I mean, I will just revert to this example. For example, you have you have to model, for example, a counter. You know the counter. This is our example for today. So just this counter actually should be what? Increase every time, increase by one, by one, by one. So if I want just write a simple program using this counter. So here we have to create a state for this counter. So now we are talking about. I mean, once we say a state, that means I'm talking about the structure, the variables of this system. Okay, the state is the variables of this system. So what we have here, this in this system, this one is the counter system. We want to model this counter. The main variables here. What the main variables here, guys? Guys,
Hello.
yes. You know, Mori, I say, oh, maybe again. So, guys, I say here we have what? We have a counter. We have a counter. I have a counter here, and I want to model this system. So I say we have three type of schema. The first one is the state, the initial, the operation. So in state schema, I say here the state schema describes the variables of the system. Okay, so what variable do we have here? The main variable here is
Counter.
counter. Yes, is the counter. So this schema, which is the state schema, should define this counter. Okay, if we don't have the type of this counter, we should to define it. If we have, we just declare this counter. So here the counter should be integer. So we have it in Z notation is available. So we just define the counter. So what do you think about? So this is about the state schema. State schema. Okay, what we say, describe the state space. That means we describe the variable and the invariants. Okay. Okay, variables and invariants. So this is the variable, we will write it here, which is the counter. Invariant, we see if our system needs some invariants or not. Okay, so we will see here, based on my description, no need, but maybe later in this example, in today's example, you will see there is one invariant. So we have another schema, which is initial, the initial one. So what do you think in the initial schema do we need to write? Initial, counter, and initial. So what we have to write there? Guys, initial and counter. So what we should to initialize? We should to initialize the counter, but what we will do, how we will initialize the counter? Once initial guys, once your system start running, once we start the system, what we have to do? Sometimes we reset something, we put this value, we like this, right? So in the counter, what we should to do? Guys, when you're writing any program, once you start any counter, you should, again what?
We set it to 0 first.
Yes, we set it to zero. That's why we reset it. It's just assign the counter to zero. So this is the initial. In the
Yes.
initial state, okay? We just assign this counter to zero. And then now we come to the operation. So the operation based on the system description. Okay, if I just say is counter, maybe we need to add one operation if only counter, So this will one increment, right? Only increment operation. The operation, that's the function that we need. So here we need only to increase it by one. So we need only one function, which is increment. Okay? So this is the state, the initial, the operation. I hope it's clear. This one actually will be with us until we finish this course. Every time we write specification, you should to mention these three operations. Maybe we have only one state, maybe we have only one initial state, and the operation based on the system description. So here in the schema, in the state schema, we have to write the the variables that we need, invariance if there is any invariance that needed. If there is, that means sometimes based on the system description, we say, for example, the counter should not exceed max number. Okay. So here we should to mention this condition here. This is, if you remember, in the location, we write invariance there. We say, for example, we should not stay in this location more than 5 units of times, right? So this is the same things. So the invariance actually is the conditions should be satisfied during the system runtime. So the second schema we have, which is the operation. As we say, the initial is just to initial any variables that we need. Initial, or we can say the initial schema, we can consider the initial schema as operation. Okay. So the second one, which is the operation, or we can say the third one, the operation. So what operation do we need based on our system description? So add an operation schema have, okay, so guys, we have here first, okay, this one, this first line, every times you add any invariants, you have to add this sentence. So what's this sentence? This sentence actually we revert to the schema, the state schema. Something like we are using the state schema. So we should to mention the name of the state schema here. Okay, for example, the name of the state schema, it was counter. So we write counter. Okay. And then here we have two symbol here. We have the delta and we have the HC. I think this is, we call it H or XC or something like this. So this one, it's the meaning of delta. That means if anything, it's if we add, for example, now we create this schema, okay, and then we have the counter, as we say, the counter, the counter, the counter. For example, if we consider the counter is C plus C equal 1. So we change the value of C, right? Of the counter. We change the value. I mean, the counter, the state counter have a variable, call it counter, right? So we change this value. We change any variable in the state schema. If we change any variable in the state schema, that means we change the state schema. So we should use delta. Okay? If not, we don't change anything. For example, our operation is just to display the data. So we don't change anything, right? So we use this HE. Okay, guys. So this one of them, and then the schema name, and then here the variables. If we have input variables or output variables. Okay. Here, guys, we have to, for example, if the variables D, so if the input we put question mark, if output, for example, output, okay, or we put exclamation. Okay. So we have here also the precondition and the operation itself. For example, as we see, we have this is adding, right? C plus 1. So we have precondition. For example, I do want to add if this x is greater than a number, if the greater than max. I don't know. I just want to increase the number. If the number less than max. If is greater than max, we should not do that. So this is we add this condition here. And then if this condition here, that means is pre-condition. If after the operation, that means post condition. Okay, guys, this is the schema, the operation schema. So this is in general, actually in state schema or operation schema, we can see we have two parts, which is the declaration and the predict. Okay, declaration and the predict. In the declaration, we declare the variables. In the predicts, we is the body of the system, body of the schema. Either is invariants or some operation. So this is the one I explain. If I mean the declaration part, we have this part, and then a predicts. And so this is I just explain all. We need to add it again. So here one things, okay, if you want to now to define or declare any variables, so just the variables name and then the data types. Okay, we have some data types here. We have n, for example, for integer. We have r for real. I think we have different type of data types. If you want to declare another things, I mean define another data types, you can also define another data types using these two brackets. Okay, for example, person, we don't have person. Customer, we don't have customer. So you just add it like this. You just add it like this. Person. Sorry, guys, my hand. Person, and we don't have this data type. So we just write this is. So now we define yes, we define data types. Later we can use it as integer or as real. So here some terms, I mean, how we can use, but this is later because we have one class only for this. So we come to our example, actually the first example and the last example. The first example in Z notation, and the last example in this class or today class. So guys, we want to model this. I just that's why I revere for this system because we have this example. So guys, as you see here, we have this just counter, and this counter here, the range of this counter from 0 to max. And here also we have a condition is we cannot increase the counter unless this counter still less than the max. Okay, and then we want to also decrease decrements by d, not by 1, but if the counter is greater than d. So we have, maybe you can see here, you have two operation, which is increment and decrement. Okay, we have to create the state schema, we have to create the initial schema. So guys, can anybody help me? How we can create now the state schema? State schema, guys. Hello? Hello?
Yes, sir.
Yes. How we can write now the state schema? Okay, guys. Actually, as you know, okay, we have this the body, I mean, of that's how schema look likes. Okay, how we can delete this? Okay, based on this condition, guys, just help me. I will do it. I will do it. We have this schema should be look like this, right? So we start first with counter, which is the state schema. Okay, we name it the same counter. Okay, counter. So in this counter, what I have to do here? In the declaration part, as we say, is the state. That's what we have here. Declaration, we have here the invariant. This is the state. Declaration, here the invariance. So what we have to write here in the declaration, or what we have to declare for this example, what we have to
Max,
again
Counter.
counter.
counter, and max. Max.
Okay, counter and max.
State variable.
And this time we can see, you see how we can same as in the slide, to semicolon, and then the tab of this. We have here n. It's just today just learn n. N is integer types. So the invariants here we have or we don't have. If we don't have, you just leave it like this. Okay, but we have. So what we have to do?
Counter should be less than
Yes, yes.
Zero. Less than zero.
Yes. Counter should be less than 0.
Greater than 0.
Greater than 0. So we should write like this. This is counter. Actually, okay, this is the name of the state, right? We cannot write the name of the state, same the counter name. You just maybe write CTR. Based on our example, we write just CTR, okay? This is remember the counter. So CTR, this is should be greater than 0 and less than max. Then guys, this is now is for the state. Initial, we can say counter or CTR initial, anything, just something like this. So in the initial, guys, what we have to write? We have to
CTR.
refer to the same state. So counter. Okay, without this one, no need. Just if you want to write it, you can. I mean, this is something like we are use this counter schema. And then here CTR what? Equal to 0. This is the initial. Initial, that's when you just reset this variable. If there is another thing you need to reset, you can reset it. So the third one, which is now, as we say, we have, based on this example, we have two operations actually. You can put it all in one, but I think it's better, as we say here in our system, in OPAL, not OPAL, sorry. In Z notation, actually, we represent each operation as a block. So each operation. So we have here counter. We can the increments. The increments just is one operation. So this is one block or one schema. Decrement is another block. So guys, in the increment, we have this state, this schema, which is decrement. Okay, sorry, this is gas decrement. If you don't know, this is decrement. Okay. So in the decrement first, what we have to do, you can go for writing the body first, and then based on the body, you see what you have to write in the declaration. So here, actually, as you see here, we have the counter should be less than max. So CTR should be less than MX. And then something like then what? If this is true, so what we have to do? CTR equal CTR plus 1. So here, as I told you, we have new operation here or new notation, which is prime here. We just add here something like comma is high. So we add it like this, something like this is the old value. No, this is the new value. This is the old value. So the new value equal to old value plus 1. So this is just we add prime. So now what we have to declare here, we have to declare what? Since this is already declared, the CTR max already declared, so just what we should to mention here, the counter or the state, which is delta what? Delta what? Guys,
Delta counter.
delta counter. Okay, guys, that's all. Now we have this is similar. The another one which is decrement, similar to this, just minus. Okay, guys, you see how simple is it? So easy. So this is, guys, the first specification. So let's see now this specification one by one. So this is in actually with the explanation here. We have this is the first schema, which is the counter. This is the schema, the state. Okay, state schema. We just declare these two. We don't have to define any variables because we already use only the available one. So here we have this invariance because we say that in our example the counter is between 0 and max. So this is the invariance. So in the initial counter, in the initial state, we just reset the CTR. Decrements or increments, not the decrements. So sorry, maybe I write there decrements. Increment, what? We just increase the counter by 1. Okay, that's why here we add delta. Next is the one I do write it, which is decrements. So the decrements reduce this by D. Okay, so here if you see here, we declare another variable which is D, because we should increase or decrease this counter by D. So next, if you want to display this data, so this is a display. We use this one because we don't change anything in the state. Okay, we don't change anything in the state. So we use this symbol, which is chi or chi, I think. So here we just have this variable with exclamation, that's mean output. So we save the counter into this output. So guys, that's all. This is all the schema together. So here you can write this one in Microsoft Word exactly like this, or you can write it in this CZT tools using this ASCII code. So there is no output. This is just you rewrite your specification. As you see here, we don't use anything related to the database. That means we don't create any set. Just counter. Just we have only counter. So we model this counter. Okay, guys. Okay, guys, I guess now we have. Okay, before I go for the next. Okay, guys, clear?
Yes.
Sure. Who say yes?
Me.
Okay, okay. Can. Good, good. Okay, guys, no problem. Anyone you can say anything, no problem. Uh, I hope it's clear. I hope it's clear. Okay, guys, since we have time, just don't forget to mark your attendance. But now we want to use this time. We have this activity. I want to discuss with your mate and then just write anything you know, anything you know. Okay, if you correct or not correct is okay, guys. Correct or is not correct, it's okay. You just write anything, just write anything, and then show me. Now, huh? Okay, guys. This is this is the example. This is the example. Just we will back 5 minutes, okay, to think about it. So, guys, okay, 5 minutes. Okay, guys, think we have to model or to write the specification. Model or the specification is the same because actually we are modeling the system. Once we write the specification, we are modeling but different. That's when we're writing the same system but different way. So here we have to write the specification for a system, and this system receive two integer number a and b, and then display the sum. See, so easy lah. We just display the sum of these two numbers. Okay, guys, we give 5 minutes and then I'll back to you. Okay. Hello, guys. Hello, guys. Yes, guys. Any answer? Guys, very simple, is not that difficult. Guys.
Sorry, sir. Using phone cannot show the screen.
Uh-huh. Uh-huh. It's okay, you can share. Use. Okay, okay, no problem. So, guys, do you have to get the idea at least? Just what we have to do. What we have to do here. As we say, we have these states, this schema, this schema. We have to build this schema. The state schema, the initial schema, and adding schema, which is the one to sum, and then display schema. Either you can even put these two together. You can combine these two the last two together. So just discussion. This is actually your lab tomorrow. You will do it. It's already uploaded the lab there. You can do it even from now. So the state schema, what you have to do in the state schema, we have two variables. So this is the schema have two variables. So we should to declare these two variables. Okay. Is there any invariance here? So in the beginning, we should to declare A and B. Invariance, we don't have any invariance here, or we have. If we have, we should write it here. It's see, check here this one, this. So this is, we can see this is the state schema. Initial schema, okay, since we receive two numbers, maybe we don't need the initial schema, but it's okay. Check either we need the initial schema or no. So we have another one, is it? Which is initial schema. So the third one, which this one, maybe you need it, maybe no.
Sir, so
Okay.
the initial schema we don't need, right, sir? The initial scheme we don't need, right, sir?
If you write it or not write it, it's okay actually. Because here we will receive two, right? We will receive two variables. So these two variables, that mean new value. I mean, once we receive two variables, two value for these variables, that mean. So if you write it or no, don't write it, is same. So the third one, which is the important one, which is adding. Adding, just also the same thing. We will just refer to first state schema. Whatever you write, this is the first state schema name. We revert to this, and then we add a plus b, for example, or to c, for example, and then print c. It's not that difficult. It's not that difficult. It's just to show how we can use these variables or this z notation to write such this example. It's not that difficult. You know, guys, you can write this one is only in one schema. Okay? But we used to write this all. But at least now you have state schema and we can say the adding schema. This is at least you should write these two. Okay, guys. As I say, we will stop here because the other is related to each other. The other things is related to from the next week. We'll try to see this one. It's similar because I was planning to reach this point here with the relation and function. Relation and function. That means we will see all the others here. Okay, but it's okay. It's just a few slides. So tomorrow or next week we'll start from this elements of specification. Okay, guys. Any question? Hello. Hello,
No.
guys. Okay, guys. If you don't have any question, as I told you, we have here the attendance. I think I don't know. You can check or no. We'll see now. Your group is here. There is bus. Oh, yes, yes. Okay, guys. You can check here or either you can just use the password. So, guys, to take your times.
Sir, So
Yes, yes,
for the project presentation, right, sir? Like we already submitted the project, but you have placed the link in Kalam saying that click
yes,
on that
yes,
link,
yes.
but the link is not clickable. Like the last time
Yeah,
I
I
saw
know
it.
that. I know.
Uh,
Because
uh,
as I say, because I did not see. It will be next week. This is sure, but I did not decide either during the lab or during the class or during. So maybe mostly we'll have the class, but the presentation will be during the lab.
oh, okay, sir. Okay.
So it will be available soon. I will inform you. Okay, stop recording also.